Our next speaker will be Fredrik Ekre, and he will talk about service monitoring with Prometheus.jl. Please join me in welcoming the speaker.
OK. So welcome to my talk. So today I will talk about service monitoring with Prometheus.jl. And this is kind of a spin-off from the package server work that we have done. So if some of you were on my talk 2 days ago, that's what we are using it for. So what is Prometheus.jl? Well, it's a Prometheus client for Julia. So that's done. But what is Prometheus? So I think it doesn't make sense to talk about Prometheus.jl without describing Prometheus a little bit. So Prometheus is an open source monitoring and alerting system. And the core of it is that it's a time series database. And it's a pull-based metric collection or scraping over HTTP. And you can do some metric labeling. It has a query language from QL, and it has some limited visualization and dashboards. So usually you combine Prometheus with something like Grafana to get pretty dashboards. So this is a small visualization of how this setup works. So in the middle here we have Prometheus, the server. And in this image to the right we have 3 different clients. So a client is basically something that provides metrics. And the Prometheus server in the middle requests metrics with certain intervals, so every 30 seconds or every minute or however you configure it. So that's why it's called a pull-based, because the server itself requests the metrics and collects them and puts them in the database. And then we have to the left some other tooling that talks to Prometheus. So for example, Grafana, which uses this query language to request data. And there's also the alert manager, which can send alerts, emails, or Slack messages or something if something in your infrastructure goes wrong. So this is just a small example of what a scrape looks like. So if you request or if you do an HTTP request, this is what you get. So I just want to break this apart a little bit. So each metric contains or consists of 3 lines, and it has a unique ID. It has like a description or a documentation string. It has a specific type. So Prometheus has 4 different primitive types, and in this case it's a counter, which is just a monotonically increasing value. And finally we have the value itself. So in this case it's the total number of allocated bytes in this Julia process. So what is Prometheus.jl? Well, that's a client implementation for Julia that implements the client specification. And this one is actually a very detailed specification in the Prometheus docs, which made it very easy to implement. So it implements these 4 basic or primitive collectors. So there are counters, gauges, summaries, and histograms, which you can provide, and then compute various statistics or metrics based on these. There is also 2 different custom collectors. So there is a process collector, which basically scrapes the proc file system, and a GC collector, which gives you a lot of statistics about the Julia garbage collection and allocation. And it's also very easy to build your own collector. OK, and this looks, well, doesn't really matter. I don't know why it's cut off. So this is basically what happens when a scrape request comes in from the left. So what you really are scraping is something called the collector registry, where you have added a bunch of these metrics. So you can have multiple counters and multiple summaries or whatever. And then you have to instrument your code. So this is a small code snippet from the README of the package. So basically what you have to do is that you need to create the collectors. So in this case, I have a counter. You need to supply a unique name and the description, and then you can use it. So here I'm just starting an HTTP server, And for every request, I'm incrementing this collector or the counter. And then the expose function here just returns the text-based format that we had a look at, this representation. All right, so time for a demo. And for those of you who were on my talk 2 days ago, this time it's a working demo. So first, just let's take a look at this example here. Maybe I can make it a little bit bigger. So this is just a small dummy program. It creates various collectors at the top. I have a dummy function which does some matrix multiplication just to get the allocations and GC working. And then I'm instrumenting my code here. I record the request time, and I record some other things here as well. And then just exposing it. So if we just go to, let's see. I can go to the next. Oh, I have to escape from this one. Go to the next. So if I'm requesting this server, this is what you get. So there's a bunch of default metrics. Here are the ones I added. So I call it my histogram. And then it's a bunch of default stuff from the Julia GC and so on. That's not super interesting to look at. So Prometheus itself has some very limited things you can do. And I think I will skip through this because the most interesting thing is when you connect Grafana to Prometheus. So here is, for example, from my dummy function, the average element, which is a gauge. Here you can see, let me update, the matrix size. So it was time-based, so every 5 minutes it loops around and does smaller and smaller matrices. You can get some, for example, the CPU usage. When we have small matrices, nothing really happening, and then it goes up. You can see the allocations. So this is the rate of allocations. So at the top here, we allocate 120 megabytes per second. You can see the number of live bytes currently in your Julia session, which I think is pretty nice. So then you can see here that the GC is working. So we go from something like 1.2 gigabytes down to 300 megabytes in this case. And here you can actually also see when the GC. So these are the rate of GC calls. And then you can see things like the request rate and the request time, and also things like this histogram where you can see the request time goes up with increasing matrix size. Of course, this is just a silly example, but you can imagine that you can instrument your code and get actual useful statistics out of this. And just as a final thing, we use this for the package servers. So if you go to this URL, it's just /metrics on the package server, then you can inspect and see what the server is doing. All right. That was my last slide, so thank you for listening.
Let's thank the speaker. We